to Excellence Link Academy. For today, we're going to be looking into an aspect called permutation. Permutation. Alright, by definition, what is permutation? Permutation has to do, or permutation is concerned with a number of ways of arranging n different objects taken R at a time. I said permutation is concerned with the number of ways of arranging n different objects taken R at a time. Permutation is represented by P. Permutation is represented by P. Hence, how do I express the number of ways of arranging n different objects taking R at a time? It is written as n permutation R. So by mathematical approach, n permutation R by mathematical approach becomes n factorial over n minus R factorial. Here is the basic concept behind permutation. Note something, please. Note that n is always greater than what? Than R. Please take this math serious. N is always greater than R. Alright, at this point, we have been hearing factorial. Let's consider the concept of factorial. What is factorial by definition? Factorial is also known as what? The symbol factorial is in English language is known as what? Exclamation mark. What is factorial by definition? A factorial is simply the multiplication of consecutive terms in descending order such that each term differs from the previous by 1 until 1. I said a factorial is simply the multiplication of consecutive terms in descending order such that each term differs from the previous by 1 until 1. What are we saying? If I have 5 factorial, we said multiplication of what? Consecutive terms, right? In descending order, right? So if I'm moving 5 into descending order, that becomes what? 5, then 4, 3, 2, 1, right? Such that each term differs from the previous by 1 until 1. So 5 factorial simply becomes what? 5 times 4 times 3 times 2 times 1. Here is the concept behind factorial. 5 factorial. If I add 4 factorial, it's simply known as what? 4 times 3 times 2 times 1. Here is the concept behind factorial. If I have 3 factorial also, it can be written as what? 3 times 2 times 1. Also, if I have 2 factorial, it is written as 2 times 1. Also, 1 factorial is simply 1. I want you to do something. Note something, please. The 0 factorial is always 1. Note that the 0 factorial is 1. Alright, note something again, please. Whenever you have n factorial simply means this n into n minus 1 into n minus 2 into n minus 3, it continues. Note that whenever you see n factorial, pick out this n first. Into n minus 1, into n minus 2, into n minus 3, n minus 4, 5, 6, 7, it continues, right? Depending on the question you are having. Now, I said, note something. We said 0 factorial is equal to 1. Note that n factorial is simply what? N into n minus 1, n minus 2, n minus 3, into that same n minus 1, that same n minus 2, that same n minus 3. Now we assume that n minus 1 is our n. We are assuming that n minus 1 is what our n. That becomes n minus 1 into n minus 1, then minus 1 into n minus 1 minus 2 into n minus 1 minus 3 factorial. It continues. Watch out for the relationship. Here I have the concept of factorial. Let's take an example and let's see how we can solve problem on permutation, right? I won't consider the concept of factorial. Let's move on to permutation. Example. Let's take an example. If you are told to evaluate, if I have, let's say, 5 permutation 4. I have 5 permutation 4, and I'm told to evaluate this. First things first, what do? We said for permutation, the idea is simply what? Take this n factorial over that same n minus that factorial. Alright, apply the same concept here. I'll be having, we said this is our n, this is our r. That becomes what? 5 factorial over that same 5 minus 4 factorial. If I proceed mathematically, I'll be adding 5 factorial over 4 minus 1 is 8. 5 minus 4 is what? 1 factorial. But we just said 1 factorial is what? It's simply 1. I have, but 5 factorial is simply what? 5 times 4 times 3 times 2 times 1 over 1. 1 factorial is simply 1. I have 1 here. If I proceed, I'll be left with 5 times 4 times 3 times 2 times 1, which is equal in value to 5 times 4 is 20. 20 times 3 is 60. 6 times 2 is 120. I have 120 as my answer to this question. So here is simple basic concept behind permutation. Let's proceed to another concept under permutation known as algebra of permutation. Alright, let's look into the concept of algebra of permutation. Having understanding the definition of permutation, and we have taken an example of permutation, let's now consider another concept known as algebra of permutation. Let's take an example and let's see how we can solve. Let's look how we can understand the concept of algebra permutation. Let's say, example, if I have, let's say number 1, I have, let's say, n permutation 2 is equal to 12. I have n permutation 2 is equal in value to 12. What do? First, I take, so I have n permutation 2 is equal to 12. This is what we call the algebra of permutation. Now, I am looking for n. That's the concept, that's the idea. I'm looking for n. What do? From the idea of permutation, this can be written as what? Solution. This can be written as what? N factorial over n minus 2 factorial is equal to 12. Right? Is equal in value to 12. At this point, please, listen. At this point, what do? Recall that we said if I have n factorial, I can simply expand this as what? N into n minus 1 into n minus 2 factorial. It continues. The reason why I'm stopping at n minus 2 factorial is because of I have n minus 2 factorial, so that they can cancel out. That's why I stop at this point. So that I will replace n factorial, this one, with all this. That becomes, instead of writing this, I'll write all this. That becomes n into n minus 1 into n minus 2 factorial over, I have n minus 2 factorial is equal in value to 12. Right? Is equal in value to 12. At this point, what do I do? This cancel out this. I'm left with n into n minus 1 is equal in value to 12. Alright, now here's what you need to note. I have 2n, n and n. Now here's the idea. This 12, I'll split it into 2. Why? Because I have 2n here. Now, here's what you need to note. I'll look for two numbers such that if I multiply them, it will give me 12. If I minus them, it will give me 1. The two numbers are simply 4 times 3. 4 times 3 will give me 12. If I minus 4 from 3, it gives me 1. So I'll apply this. That becomes n into n minus 1. I have this. So now I will equate it this way. N is equal to this 4. And also, n minus 1 is equal to 3. Separating them, I will be having n is equal to 4. This is equal to 4. Also, I'll be having n minus 1 is equal to 3. At the end, n is equal to 3. This one becomes plus 1. I have n is equal to 4. So my n is 4, my n is 4. Here is how to solve problem on algebra permutation. Let's take another example and let's see how we can solve the example using the idea of algebra of permutation. Alright, let's take example 2 under algebra of permutation and let's see how we can solve the question. I have n permutation 4 is equal in value to 12 multiply n permutation 2. What do I do at this point? The same concept as I did the previous example. Let's apply the same concept. Solution. We said n permutation 4 can be written as what? That becomes n factorial over n minus 4 factorial. I have this is equal to, I have 12 multiply n permutation 2 can be written as well as what? N factorial over n minus 2 factorial. I have this at this point. So I'll expand n factorial to what? To reach n minus 4 factorial. So now, we said this can be written as what? N into n minus 1, n minus 2, n minus 3, n minus 4 factorial. It continues, but I will stop here because I want this to cancel out with this. So over, I have n minus 4 factorial. It's now equal to, this is 12, multiply n factorial can be written as well as what? N into n minus 1 into n minus 2 factorial over 2 over what? N minus 2 factorial. Hence, this will cancel out this will cancel out this. I'm left with n into n minus 1 into n minus 2 into n minus 3, right, is equal to 12 into, 12 multiplied by n into n minus 1. That's all, right? This cancel out this cancel out this. I'm left with all these terms equal in value to all these terms, as you can see. Now in mathematics, we're going to do some manipulation here. In mathematics, whenever you have two terms, let's say you have a equal to a, you're having the same term in the opposite side, it can cancel out. Alright, if I have, let's say I have a b squared is equal to vb. I'm seeing b here, I'm seeing b here, and equal to equality sign between them. Hence, this will cancel out this. I'll be left with b. So yes, one concept behind mathematical manipulation. Alright. n minus 3 is equal to 12. From the idea of our previous example we did earlier, I am having n, just 2n. Look for two numbers. When you multiply them, you have 12. The difference between those two numbers will be 1. That becomes, I will have both 12 and 3, right? So, b equal to n minus 2, n minus 3. Now, I'll pick out this with 4, pick out this with 3. I'll be having n minus 2 is equal to 4. I'll be having n minus 3 is equal to 3. Remove the bracket, I'll be having n minus 2 is equal to 4. Hence, my n is equal to 4 plus 2. N is equal to 6. At this point too, I'll be having n minus 3 is equal to 3. Hence, n is equal to 3 plus 3. N is equal to 6. Here is my answer after solving. Here is simply concept behind algebra of permutation. Let's move to application of permutation. Let's consider the concept of application of permutation. So after defining permutation, we took an example, we evaluated a question of permutation. Having done that, we discussed about the algebra of permutation. Also, now we are into application of permutation. Now, what is the concept behind application of permutation? This concept always comes out every year. Both the past questions I've been saying, it do come out. Please, let's take this concept serious. Now, for the application of permutation, there are three ways at which we can apply permutation. First is first, we have number one, we have the distinct arrangement of distinct objects. We have the arrangement of distinct objects. I have number one. Number two, I have arrangement of repeated objects. Arrangement of repeated objects. Also, I have circular permutation. Alright, these are all the concepts we need to discuss under the application of permutation. First is first, we have the arrangement of distinct objects. Two, we have the arrangement, there's an E here, arrangement of repeated objects. Also, we have circular permutation. Let's discuss arrangement of distinct objects. Arrangement of distinct objects. Of distinct objects. Let's discuss arrangement of distinct objects. Put down this, right? Arrangement of distinct objects is applied. Arrangement of distinct objects is applied when the objects are not repeated. Or let's say perhaps you can say when the objects that are meant to be arranged are not repeated. So that is the concept behind arrangement of distinct objects. Let's take an example. Let's take an example. In how many ways can the words be arranged? In how many ways can the word be arranged? A. Let's say I have Lagos. 2. Let's say I have fasting. And 3. Let's say I have cap. Alright, let's say I have cap this way. Now the question says, in how many ways can the word be arranged? A. Lagos, fasting, and cap. First things first, what do I do? What I want you to understand here is that we said arrangement of distinct objects. We said, when I define this for you, I feel that this can be applied when the words, or let me say objects, you are told to arrange are not having anything in common. Listen, look at this place. L is different, A is different, G is different, O is different, S is different. They are all different objects. F is different, A different, S different, T, I, N, G. They are all different objects perhaps. C, A are different. So you apply the concept of what? Arrangement of distinct objects for this one. Right? For this one. So now let's look how we can solve this problem. Solution. First things first, I have A. We said, in how many ways can a word be arranged? Lagos. I have Lagos. So my idea is that we are going to count the number of objects here. I have 1, 2, 3, 4, 5. That becomes 5 permutation 5, which is equal in value to 5 factorial over 5 minus 5 factorial. Hence, I have 5 factorial over 0 factorial. But we said 0 factorial is 1. Hence, I'll be having 5 factorial is simply 5 times 4 times 3 times 2 times 1 over 1. Hence, I'll be having 5 times 4, 20. 20 times 3, 60. 6 times 2, 120 ways. 120 ways. So, in how many ways can the word this be arranged? 120 ways. Alright, let's look at 2. Question 2, that is fasting. You do 3 for me. I'll do 1, 2. You do 3 for me. Fasting. Let's look at fasting. For fasting, let's count the number of objects there. I have 1, 2, 3, 4, 5, 6, 7. 7. That becomes 7 permutation 7. Which is what? 7 factorial over 7 minus 7 factorial. Hence, it becomes 0. I'm left to place 7 factorial. That becomes 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm left with 7 factorial. 5040 ways. That's for 7 factorial. Let's do 6. So, okay, I said you should do 3 for me. After doing 3, put your answer in the comments below. Alright, let's take one more example. And okay. Let's move to the second concept. We have considered for the arrangement of distinct objects. Let's move to arrangement of repeated objects. So, alright, let's consider arrangement of repeated objects. Let's take example under this. Now, before I take example under this, the previous application we discussed was arrangement of distinct objects. In that case, those words are not repeated. But in this case, those words are repeated. Let's say, for instance, let's take an example and let's solve it and understand the concept behind arrangement of repeated objects. Example. In how many ways can the word be arranged? Let's say number 1, I I have Mississippi. Abuja. Alright. In how many ways can the word be arranged? I have all this. If you observe closely, from a good example we did, when we listed the objects, they are not repeated. But in this case, these objects are repeated. Is M repeated? No. Is I repeated? Yes. In how many times? 1, 2, 3. 3 times. X 1, 2, 3, 4. P 1, 2. You can see that for this concept, that's what we call it arrangement of repeated objects. The objects are repeated. Now, how do you solve this one? How do you solve this solution? Let's solve this and let's see. I have Mississippi, right? Mississippi. How do I solve this? First things first, count the total objects here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11. That becomes 11 factorial over. Now, count the objects that are repeated. Is M repeated? No. Next up, Is I repeated? Yes. 1, 2, 3, 4. That becomes 4 factorial. Alright. Is X repeated? Yes. How many times? 1, 2, 3, 4. 4 times. That becomes multiplied by 4 factorial. I'm done with M, I, X. Let's go to P. 1, 2. P is repeated 2 times. That becomes 2 factorial. So we said the idea is what? Count the total number of objects as the numerator. The repeated object will serve as what? The denominator, as you can see what's on the board. Next up, I know that 11 factorial is simply what? 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over. I probably use 4 factorial because I have 4 factorial here. I cancel out 4 factorial multiplied by 4 factorial multiplied by 2 factorial. This can cancel out this. I'm left with 11 multiplied by 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 over 4 factorial is what? 4 times 3 times 2 times 1 multiplied by 2 factorial is what? 2 times 1. At this stage, if I punch numerator, I'll be having 11 times 10 times 9 times 8 times 7 times 6 times 5, right? I'll be having 1663200 divided by, if I put calculator, 4 times 3 times 2 times 1 times 2 times 1, I have 48. So if I divide numerator by denominator, I will have 1663200 divided by 48. I have 3, 4, 6, 5, 0 weights. So weights. Let's do that. So Mississippi can be arranged in in what? 34,650 weights. I will do B, you do C. Put your answer in the comments below. So if I want to do C, for my C, I have Abuja. First is first, what do we say we do? The first approach is to count the number of objects. I have 1, 2, 3, 4, 5. That becomes 5 factorial over. Now, let's start with A. How many times? 2 times 1, let's move into the last concept behind application of permutation, which is what? Circular permutation. Circular permutation. For circular permutation is a permutation, or let me say it's a way of arranging objects in a round manner. The way of arranging objects in a circular manner, or perhaps in a round manner. For this one, its formula is given by the formula for this is given by n minus minus 1 factorial. Here is the formula to circular permutation. Let's take an example, and let's say we can solve the example using the concept behind circular permutation as an aspect of the application of permutation. If I have a question this way, in how many ways can 8 people be arranged in a circular table? I said, in how many ways can 8 people be arranged in a circular table? I have my n there in that question is what? Is 8. Hence, I apply the formula, which is what? Recall that the formula for anything circular is what? N minus 1 factorial. Hence, my n here is what? 8. That becomes 8 minus 1 into factorial. I have 8 minus 1 is what? 7 factorial. And if I punch 7 factorial, I will have 5040 ways. So here is how to solve question under circular permutation. Here is all what you need to understand behind the concept of permutation. Let's use past questions under permutation and let's end today's class.